There are three methods that we can use to analyze the null hypothesis: critical value, probability, and confidence interval. With the probability method, what we're going to do is compare our p-value or probability value that we calculate to our alpha value that we selected. If p is less than the alpha value, then we're going to reject the null hypothesis. If p is greater than the alpha value, then we are going to fail to reject the null hypothesis. Again, this goes back to the court of law where you are either proven guilty or not guilty. You're never proven innocent. There are different tests based on the type of data that we have, as well as what factors do we want to compare to each other. So using discrete data, we use a discrete X and Y test. Using continuous and discrete data, we have to determine, are we going to measure variance, spread, or mean, central tendency. If it's a test that we're trying to determine are variances different or not, we're going to have a test for equal variance. If we use the mean or the middle of our data, we have to determine if our data is normal or not. If our data is normal and we're comparing one sample to a target, then we use a one sample t-test. If we're comparing two samples to each other, two independent samples to each other, then we'll use a two sample t-test. If we're using two dependent samples, and a lot of times this is done in pharmaceutical companies with before and after because it is the same people. We then use a paired two sample t-test. If we still have continuous data and we're comparing means, but we have more than two samples, we're going to use a test called ANOVA, a one-way ANOVA, which stands for analysis of variance. If we have multiple factors and multiple two or more factors and more than two samples, we're going to use a two-way ANOVA. In hypothesis testing, there are two types of errors. Type 1 error or alpha error is the probability of rejecting the null hypothesis when it is actually true. The accepted value of alpha error is 5% or 0.05. What we do is compare that calculated p-value that we got in our hypothesis test, and we compare that to our alpha value of 0.05. If our p-value is less than 0.05, we will reject the null hypothesis. If our p-value is greater than 0.05, then we will fail to reject the null hypothesis. The second type of error is referred to as type 2 or beta risk. The beta risk is the probability of failing to reject the null hypothesis when it is actually false. The beta risk is all based on sample size, and the typically accepted beta risk is 10% or 0.10. If we're trying to calculate power of the test, we're going to use 1 minus beta. If we select a beta value of 0.10, then the power of our test would be 90%.